In this video, I want to review all of the things we can do with MiniTab output, and it'll give us a chance to talk about regression a little bit more. Below is the MiniTab output to assess whether linear regression can be used to predict pet expenses for a lifetime from household income using a sample size of 50. So you can see our data here. Remember that the constant piece is our y-intercept, and all of this row then has to do with y-intercept. The income, right? You can see all of the income pieces. This is our slope, and all of that row has to do with slope. So first, let's find the regression equation. Okay, so remember, kind of the easiest way to handle that is do your response variable hat. This signifies it's a regression equation. It's the y-intercept plus slope times the explanatory variable. Next, interpret r squared in context. So if you'll remember, the r squared is, percent variation in the response variable that can be explained by variation in the explanatory variable. So I have done that here. You can see percent variation in expenses that can be explained by variation in income. And of course, our r squared is 91%, so we would say 91% of variation in expenses can be explained. Often in MiniTab you don't get correlation. It's easy enough, of course, to calculate, a square root of 0.91. All right, interpret the slope in context. So some things to kind of catch here for slope. Remember, it's for each additional explanatory what is predicted to happen to the response. And that's a key word, that predicted, because it's just a regression equation, right? So for each additional dollar of income, expenses are predicted to increase by, and we then just put the number in 0.511, I guess, fit this in as best I can, okay? All right, interpret the y-intercept in context. I'm going to quick put this down here, and then I'll move it up in place, but otherwise it's just a little hard to read. So again, I'll put the number in 438.525. This is the amount that's predicted if the explanatory were 0. Okay? So again, let me just move that up and out of our way up here. So make sure you can interpret those things. Find the value of a residual of a person who has a household income of $25,000 and spends $13,000 on their pet. Residuals have this formula. Residuals equal the actual value minus the predicted value. So for us, we have an actual value. It's $13,000, but we don't have a predicted value. So how we would get the predicted value is by plugging our explanatory variable 25,000 into our equation. Okay, so if I want to write that out kind of in the long form, I would say, all right, so it's 438.525 plus 0.51145 times 25,000. Okay, and whatever I get, that's my residual, because that's the actual 13,000 minus what the line would have predicted. And if I actually type this in, I get negative 224. I guess since it's dollars, we could go to 78 cents like that. Okay, assuming all conditions for a hypothesis test have been met, perform at the 0.01 level a test to see if there is a positive association. Okay, so let's do this right here. Our state, the null, is that the slope is 0. The alternative, in our case, we're checking for a positive like this. And remember, we always say something is the population slope between income and expenses. The plan, well, all conditions have been met. I'm going to put a little check mark there, but we were told conditions were all met for our Lin Reg T test. I'm just going to write the test we're going to use. Okay. The do, well, easy enough. We've been given a lot of information on our MiniTab output, right? Here's that slope line. So we got the slope, we've got the standard error, we've got a t-statistic, and we've got a p-value. Please recall that this p-value represents the not equal to alternative. But, of course, easy enough to calculate the greater than, we just divide it by 2. And since it's 0, dividing it in half, it's still going to be 0. So the one thing we have to kind of modify here is we've got a t-statistic. We've got to write degrees of freedom. We had a sample size of 50, so we have 48 degrees of freedom. Remember, it's for lines, it's always 2 less. So our t-statistic was 22. Our p-value is 0. And let me write my conclude just over here. We are going to reject the null because the p-value is less than 0.01. And what does that mean? We have evidence of a positive association. Okay? All right, let's answer that last question. Create a 95% confidence interval for the slope. I want to remind you of this thing that's on your formula sheet, that the basic confidence interval is the statistic we're building the interval for, so for us the slope, the critical value, which is either t or z star, and the standard deviation of the statistic. So for us, and remember, this is given to you, right? That this is the way confidence intervals work. We're going to have the slope, 0.51145, plus or minus we'll come back to critical value. And the standard error is given to us, 0.02325. So now we need a critical value, which for us, this is going to be a t star and 48 degrees of freedom. Okay, so we can go to our charts, right, that are given to us in the EP exam, and we can use, we're doing 95%, so we go to 95, and you'll notice on the side that we don't have a 48 degree of freedom thing. So, a lot of times we can just kind of go to the closest. We maybe should err on the side of the smaller one. So I'm going to use a 50 because typically you see books use the one that's closest. But again, I just wanted to point out that you really could make a justification for using either, and you really could make a justification for using like 2.01, just going a little bit larger. And then if you actually did calculate this, you get a lower of 0.46, I'm going to round, 0.465, and an upper of 0.558. So we are 99 or 95% confident that the true slope lands somewhere in there. The biggest thing I want you to see here is that, remember, all of these confidence intervals follow the same formula, that it's statistic plus or minus that critical value, either t or z, and then the standard deviation or standard error. So we were able to fill in most of that, of course, from MiniTab, and then we just need to use our chart to get our critical value.